So hi everyone, welcome to my YouTube channel. Myself Sanjay Reddy. I am from Sri Venkateshwara College of Engineering. Semester first. Today we are going to discuss about polar coordinates. Polar coordinates. The non-uniqueness of the polar form is the major difference between the rectangular and polar systems. Steps employed and solutions obtained in the rectangular x and y equations. When applied to the r and theta, polar equations have to be reinterpreted in light of the polar geometry. Example, interpret and draw the graph of each of the following polar equations. Convert each equation into a corresponding rectangular form. R is equal to K. The polar equation states that the distance R from the origin to our points is a constant K. This is the circle of radius K centered at 0, 0. Polar coordinates. Discover the power of polar coordinates as we explore their definition, conversion to Cartesian coordinates, graphing techniques, and common equations. Uncover their applications, advantages, and disadvantages in various fields. Definition of polar coordinates. Polar coordinates provide a method to represent the position of a point in a plane using its distance from the origin and the angle theta it forms with the positive x-axis. Conversion between polar and Cartesian coordinates. Learn how to convert between polar and Cartesian coordinates to seamlessly switch between different coordinate systems. Explore the formulas for conversion and deepen your understanding of their relationship. Graphing polar coordinates. Unlock the secrets of graphing polar coordinates to create beautiful and complex patterns. Master the plotting techniques and get ready to explore the fascinating world of curves, spirals, and symmetry. Common applications of polar coordinates. Discover the wide range of applications of polar coordinates, including curve sketching with polar equations. Explore how polar coordinates are used in physical engineering and mathematical contexts. Advanced topics in polar coordinates. Unlock the potential of polar coordinates in three dimensions and explore their applications in parametric equations. Dive into the fascinating world of advanced polar coordinates concept. Conversion between Cartesian and polar coordinates. Cartesian to polar. Discover the formulas for converting Cartesian coordinates to polar coordinates. Explore real-world examples to solidify your understanding. Polar Cartesian. Learn how to convert polar coordinates to Cartesian coordinates using clear step-by-step instructions. Practice with various examples. Polar coordinate standards. 17th century. The concept of polar coordinates was introduced by Isaac Newton and Bartholomew. 18th century, Leonhard Euclid developed the modern notation for polar coordinates. 19th century, Auguste Mobius made significant contribution to polar geometry. Calculus in polar coordinates. Explore the applications of calculus in the realm of polar coordinates, including finding slope, concavity, and arc length of polar curves. Real-world applications of polar coordinates. Discover how polar coordinates are utilized in various fields such as physics, engineering, and navigation, enabling precise calculations and measurements. Steps for finding other polar coordinates. Subtract 360 or 2 pi to get a negative angle. Add 180 of pi to change the r to negative halfway around the circle to be on the other side of the polar graph. Add or subtract 360 or pi to find the other angle. Steps for converting from rectangular to polar coordinates. First step is always plot the point x comma y first. Second is to find r comma r2 is equal to x2 plus x square plus y square. To find theta, remember that we only know x and y. Therefore, the trig value that we can use involves only x and y tangent. Tan theta is equal to y by x, theta is equal to tan inverse of y by x. Polar equations of circles. The equations r is equal to a. The equation r is equal to a is a circle of radius mod a centered at the pole. The equation r is equal to a cos theta is a circle of radius passing through the pole and with the center on theta is equal to 0 or theta is equal to pi. The equation r is equal to a sin theta is a circle of radius passing through the pole and with center on theta is equal to pi by 2 or theta is equal to 3 pi by 2. Tangents to polar curves. Given a polar curve r is equal to f theta, the Cartesian coordinates of a point on the curve are x is equal to r cos theta is equal to f theta cos theta, y is equal to r sin theta is equal to f theta sin theta. Hence dy by dx is equal to dy by d theta by dx by d theta is equal to dr by d theta sin theta plus r cos theta divided by dr by d theta cos theta minus r sin theta. Rose curves. The equation r is equal to b sin of a theta, r is equal to b cos of a theta. Both have graphs that are called Rose curves. The Rose curve has 2a leaves. If a is an even number, the Rose curve has a leaves if a is an odd number. The leaves have length b. To graph Rose curves, pick multiples of pi by 2 area of polar coordinates. The hardest part of this is determining the limits of integration. This is done as follows. Step 1. Sketch the region R whose area is to be determined. Draw an arbitrary radial line from the pole to the boundary curve R is equal to theta. Ask over what interval of values must theta vary in order for the radial line to sweep out of the region R. Your answer in step 3 will determine the lower and upper limits of the integration. Finding all polar coordinates of a point. Let the point P have a polar coordinates r, theta. Any other polar coordinates of P must be of the form r, theta plus 2 pi n or minus r theta plus theta of 2n plus 1 pi, where n is an integer. In a particular, the pole has polar coordinates 0, theta, where theta is an angle. Applications of polar coordinates. Witness the broad range of application where polar coordinates prove to be powerful tool from physics to engineering, astronomy to image processing. Explore real world of scenery where this coordinate system shines. Advantages and disadvantages of using polar coordinates. Uncover the strengths and weaknesses of polar coordinates in different contexts. Understand when they outperform Cartesian coordinates and where their limitations may pose challenges. Gain insights into their optimal usage. Conclusion. Wrap up your journey through the realm of polar coordinates. Celebrate the versatility and elegance of this coordinate system and inspire others to embrace its power in their exploration of mathematical and scientific domains.